Hello everyone. Today we're gonna present about our mechatronic projects. We are from Group 6, consists of Omer, Nasif, Abde, and me, Adam. So our project's name is Cats Feeders Board. Uh, Next. So for introduction, for our idea, is to design, develop, and simulate a mechatronic cat feeder that automates the feeding process, ensuring consistent and accurate food dispensing for pet cats. An automated cat feeding dispenser utilizing mechatronic principle that utilizing mechatronic principles. The concept seeks to tackle common issues faced by pet owners, such as ensuring regular feeding routines through the use of mechanical components, electric control system, and software programs. In this presentation, we will explain the problem statement, objective, project method, and workflow, and our final results. Uh, For the problem statements, so modern cat owner, especially those who work irregular hour or often always struggle to feed their cats on time. Busy people find it hard to follow a feeding schedule. Manually filling a cat's bowl can cause overfeeding, underfeeding, or missing meals. Overfeeding pets cause obesity and health problems, while underfeeding or missing meals cause malnutrition and stress. Inconsistent can harm uh, cats' health and causing long-term issues. Additionally, current automatic feeders often ignore this issue. This device often lack of precision and flexibility cats need for diet. Some feeders dispense food irregularly or in incorrect portions, causing similar issue as manual feeding. Some lack of some lack of monitoring and adjustment feature, making it hard for cats owner to change their eating habits. Unreliable performance and limited functionality can make it harder to feed a cat a balanced diet by creating an unsuitable feeding routine. Managing cat routine with a busy and or unpredictable lifestyle requires more advanced and customizable feeding solution uh, that we are consistent, accurate, and easy to use.
Thank you, Adam. And we are trying to build on what Adam have said. So basically, there's a lot of concerns for pet owners to feed their cats manually, and it's kind of a headache and sometimes time consuming. So what we are trying to do is to find a solution for these problems through mechatronics and make something that can be easy to use and more friendly to the user. So what are we going to do is to design a virtual 3D model of the automatic cat feeding robot using Tinkercad, make a user-friendly interface uh, to the design consisting of control buttons for customizing the feeding times and display the show time and date. And also to validate the performance of the design prototype through virtual simulations using Proteus. So, what is our project method? As we have said before, there's a lot of issues concerning these pet owners. So, what we're trying to do is to determine these needs and incorporate it into our automatic cat feeder. So, the pet owner's main concern is irregular feeding schedules and manual feeding, which are going to be addressed. So, we are trying to see the requirements for it And firstly, it's the scheduled and customizable feeding, easy feeding timer, food dispenser that works well, and real-time feeding updates. So the tasks is to survey the pet owners to assess the needs. That's what we're doing. This the first step. To determine the cat feeder's main goals and functions, break the requirements into mechanical, electrical, and software parts. So after that, designing a concept that meets these requirements with mechanical and control design help. So these what are we going to incorporate into our model? A mechanical design, electrical design, and a software design. So we're trying to do the mechanical design is to make something that looks nice and something that looks more appealing to the customer. So we created a 3D feeder model in Tinkercad. So it includes a food storage, dispensing mechanism, structural components, and we made the design easy to assemble and maintain, so it doesn't break easily. We made slots for the ultrasonic sensors, the servo motors, and the displays. For the electrical design, we used Proteus software to design the circuit. We can use real life design to portray our model, but maybe with more time we could have done that. But for now, we just used an online software called Proteus to design our circuit and to simulate it. We added a microcontroller, a servo motor, an ultrasonic sensor, buttons, and a display. We also created a schematic diagram for the component connections. For the software design, we added a we did a control we controlled the feeding schedule. We put a sensor we inputted a sensor and a motor with control program. We created a feed timer and date display interface. We also made a simulation using Proteus to test the program. Moving on to
Okay, so for the 3D model implementation, first thing you need to know is that we implemented this model using Tinkercad. So this page actually shows bits of the work we actually developed using Tinkercad. So for the diagram on the far left, you can see the front view of the robot. So while actually coming up with the measurements, we tried to make sure that it's compatible for adult cats, the average size of adult cats. So we came up with this measurement, as you can see here. And the figure next to it actually shows the side view. And here you can actually see sort of what's on the back of the robot that shows a food storage and a circuit compartment. So basically the black part actually shows the food storage, and below it, just below it, is the circuit compartment. And if you notice closely, you can see that the base of the food storage is a bit inclined, and it's meant to be that way so that the food inside can naturally crawl into the bowl inside later, much easily. And after that, we show the measurements for the storage box, the food storage, also the top view, and the overall look. Next. Okay, so now we shall show the video we developed on the 3D design on Tinkercad. So here we just go around the design, showing the overall layout. So inside the robot, as you can see, there's a red bowl, and on the red bowl, there is actually a green part, which is actually an ultrasonic sensor, which will be used to detect the presence of food inside the bowl. And if we go inside the mouth of the cat, all the way inside, you can see that there is a blue part inside. That's actually the gate that goes vertically upwards and allows the food inside the food storage to crawl on the inside and into the bowl. So now going to the back, there are actually some buttons and an LCD display that the user can use to set the timing of when the food should be dispensed automatically. It also comes with a clock that actually shows the real time, the time, and also the date. Okay, so normally the lid is actually supposed to be connected to the box by hinges, but we didn't actually include that in the design. So we're just going to remove the cover to show what's on the inside. So yeah, as you can see on the inside, currently it's empty, and the wall that's actually adjacent to the main body of the robot, it can actually be lifted upwards. By right, it's actually supposed to be done by servo motor, but here, of course, for demonstration purpose, we're just pulling it up. And then there at the base, you can see that there's a separate compartment to contain the circuitry, which includes the Arduino and also the connection to the sensors that were used along with the robot. So that's basically it for the 3D design.
Okay, the next thing is our circuit assembly and the software integration. As you can see in the pictures here is our built circuit that was made in the software of Proteus. We utilize the sensor of the ultrasonic sensor to detect the level of the food presence on inside the bowl, and there is the display LCD display here to display the time and the date. We use the technology of the real clock system at the bottom left of the picture. As you can see, it is to check the current time and to schedule the timing of the feeding time. And our software integration is basically we utilize using the codes for the microcontroller of Arduino Mega 2560, and we make the simulation and the debugging process in the software of Arduino IDE. You can continue to the next slide. Yeah, these are our flow chart. Yeah, maybe you can we cannot really see it clear, but as you can see here, the program starts by initializing the system, which is by pressing the power button, and then we start for the first timer. We resetting the schedule time by pressing the reset button, and then we set the feeding schedule. So here in our system, we divide our schedule into 3 parts. The first schedule is 2 times a day, where we divided our feeding time between 8 a.m. and 6 p.m. or 18:00. And then the second one is 3 times a day, where the timings is 8 a.m., 1 p.m., and 6 p.m. And the third one is the 4 times a day, where it starts from 6 a.m., 12 p.m., 6 p.m., and 11 p.m. And after that, after setting the time, so the system will check with if there's a presence of the food inside the bowl, and this is utilizing the sensor of ultrasonic sensor. And if the bowl is empty, it will automatically trigger the servo motor to open the sliding door and to dispense the food that has been pre-filled in the compartment. And then it wait for a few seconds to let the food going down, and then it directly close the sliding door. And then we utilize the looping from the code to reset start again from the keep rechecking the schedule time. And you can continue to the next slide. Yeah, this is the video of our simulation for the Proteus simulation. As I mentioned before, there's the real-time clock. Here is to record the current time and to detect the correct real time on feeding schedule. And on the right side, you see the buttons for the signals, whether you choose to the setting of 2 meals a day, three times, or 4 times. And in this video, we will try to do the simulation for the choosing 4 meals a day. As you can see here, the left side is the coding. Yeah, it gives the signal for 4 meals a day, and it shows displaying the current time and the display and the current date. It says here is almost 11 p.m. Yeah, Yes, the simulation is running a bit slow because of the Proteus software. Yes, you can see here the ultrasonic sensor doesn't detect any food at the bowl. So that's why it triggers the servo motor here to open the sliding door, and it rotates back to directly close the door. And here we see if it detects food, so the servo motor doesn't rotate. Yeah, since there's presumably food, so the servo motor not triggered, and it is not dispense any food anymore to the bowl. So we are assuming at the time maybe the cat hasn't ate its food before the schedule. Yeah, that's all for our simulation.
All right, thank you. Thank you, Update. Thank you, everyone. So this was our Group 6 Mechatronics project. And if you have any questions, you can comment down below in the video. All right, thank you, everyone.